операций. Так, в сентябре 1943 года ими был заминирован и подорван фашистский линкор «Тирпиц». Гигантский корабль водоизмещением в 51 тысячу тонн.
Yes, thank you, Sergey. All right, now, complex numbers and introduction, and a brilliant invention indeed. So in the 18th century, it was declared that, or introduced that, I is the base imaginary number. So that's lowercase I, such that I squared equals -1, which suggests that I is the square root of -1. Okay, so that's important there. I is the square root of -1. This is related to a solution. A simple equation, x squared equals -1. X equals plus or minus I. Here's some examples. For the square root of -9, so you treat it like how you've treated surds in the past. You can go something like that, which is okay according to our laws, and you could rewrite that as such. And we've got, sorry, just fix that up there, 9 by root 9 times square root of -1, and that would be 3 times I, because I is the square root of -1, so we have 3I. So the square root of -9 can now be found. Yes, it is a breakthrough, and it is 3I. Now you can also amaze your friends at parties, alright, with, yes, you can solve this with the quadratic formula. Subbing A, B and C into the quadratic formula, you can see we've got there, and you think, oh look, the discriminant is negative and there are no real solutions. No, there are no real solutions, but, and you can see that we can take those next two steps there, and continuing on, we've got similar process to what we saw just above there, and splitting up the surds there, and we can go further than that. We can go, that's 2, square root of -2 is 2 times square root of -1 over 2, and we've got -2 plus or minus 2 root 2 I over 2, common factor of 2, we have -1 plus or minus root 2 I over 1, just root 2I. So that's an example of a complex number. Complex number. So it involves I. So let's define that properly now. So if we look at our number system here, this relies on some prior knowledge, which you should have if you're watching this video. So if we start with natural numbers, we go out to integers, rational numbers, real numbers, which is the extent of something like math methods or maths B, junior mathematics in high school. Beyond that, complex numbers, and for all intents and purposes that's it. But okay, there are some esoteric things that go beyond that. However, generally speaking, that's it. So it's a boldface C, so you'll see it as like a C with, it's got a little bit of thickness in the font there, you know, a bit like, as you know, you might see integers as Z, and it's got that sort of boldface font. So C is the same, and it refers to complex numbers. So C is the set of A plus BI. So you can sort of see that form, A plus BI, such that A and B are real numbers, and I is an operator which stays as I. Okay, so the BI part is an imaginary number. It exists, but it's called an imaginary number. There's a story that goes with that some other time. And A is a real number, and together they make a complex number. Note that A can be equal to 0. It is possible. You won't see it much, but sometimes your A is equal to 0 is possible. So you would just have something like, that's an L, possible 7i, still called a complex number, 0 plus 7i. Can B be equal to 0? Well, technically yes, because complex numbers subsumes real numbers. So if we had B equal to 0, you could have something like 7 plus 0i, which is 7. So technically, anything that's a real number is complex. But it's not how we usually use complex numbers. It's a bit of a waste doing it that way. Now, a bit of notation. So if we have some general complex number, Z is very often used. Okay, that's a small lowercase z too. It's not. I don't mean integer z. No, I'm not talking about that. That's a little z. If that generically is A plus BI, some complex number, if we say RE of Z, like that, that's the real part of Z, and that's equal to A. So that's the real part. And if we say IM, that's the imaginary part of the complex number Z, and that would be B. You can see them up there. Okay, so that brings us on to the last part of the video. We're talking about equality of complex numbers. Once we know all of the above, we can look at equality of complex numbers. So if we have, if it's given that something, here's an example, given that 4 minus 3i equals 2a plus bi. All right, we look at the real parts and the imaginary parts, so we equate parts. All right, so equating parts, looking at the real parts, 4 would be equal to 2a. So a is equal to 2. And finding b, bi equals negative 3i, so we can drop the i's, b equals negative 3.